evening and welcome back to Tinkering with Edkelar. In the last episode, I tore apart a Revox A720 and A722 combo to refurbish them and make them a functioning system again. If you haven't seen that part yet, watch it first. Go on, I'll wait. All back? Good. Now let's see how the project continues. The rotary switches get some cleaning too, but since those are gold-plated, there was hardly any grime on them to begin with. Rifa. After fixing all the parts to the PCB again, it's time for assembly. Starting with the frame and the wiring loom. Now for the power supply. Adjusting the DC voltage rails. Plus 32 volts, plus minus 12 volts. The plus minus 5 and 20 volt rails, as well as the 180 volts for the Nixies. All within spec. Good. Up next, connecting the input amplifier PCB, sporting its spiffy new RCA sockets. The yellow ones are almost white anyhow. The tuner assembly and switch matrix is an exercise in PCB origami. It has two interlocking boards to carry all the traces across the matrix. After a bit of fiddling, I can add it to the front of the chassis. The switchboard and selection boards go in next, along with the meter board. I'm keeping the radio parts out for now and wrap the connectors to prevent shorting out some power rails. Turns out that the factory botch is a delay circuit to connect the output signal. Originally it went through a switch that is on the same button as the mains power, but either they decided it needed more delay, or they decided it would be bad to short out the final stage of the output circuit when turning the thing off. Either way, their own revision 2 of the button board shows the exact circuit on the regular board. This addition seems to retrofit the idea. Suits me, so this one stays. And now, finally, power on. I'm sending the output of a smartphone media player to the aux input and connect my headphones to the phone output. Nothing! A bit of poking and prodding later, I found that the phone output connector came loose. After testing the phono inputs with my turntable and the tape input with my Technics deck, I am satisfied that the AF portion works well. Nice! The connection between the two devices can be made with a 5-pin DIN cable. This will not just carry the audio stereo signal, but also an enable signal. The signal will turn on the amplifier if the option is wired up. But in true 1970s design, the standby circuit on the primary uses a resistor to drop down the input AC voltage to 12 volts for controlling a triac. These resistors are powered on all the time when the cable is connected. And you can see the result on the electrolytic cap. Toasty! I tried to retrofit a higher resistor value, but that also heated up quite a bit, and the controlling circuit didn't even respond to a wake-up signal, so I decided to disable the circuit and just use the normal on-off button. Keeps things cool. Removing the volume potentiometer and reconnecting the audio input lines to the proper locations worked out okay, although the wires are a bit tight now. also replaced the RCA sockets on the amplifier. And now the test. Connecting up one channel first and trying it out with an input signal from a smartphone. Yay, sound! Also, thanks to Hurgotron for finding a version of the schematic that shows the voltages to look for in the idle current adjustment. None of my copies of the schematic had that remark on them. The relay for the delayed output turn-on was emitting quite a bit of heat. Yikes! It is an 18-volt one that is driven from a 20-volt rail. I tried and successfully reduced the current by adding a set of resistors. Now it's half the current at half the voltage and just barely above ambient temperature. Also, much easier on the rectifiers. The signal meter also needed a replacement. Initially I thought I might reuse the original one, but it was broken too. The coil is glued to the needle holder on top, but the glue seems to have a chemical reaction with the coil and the needle, resulting in an open coil wire and a needle which just is held on by thoughts and prayers by now. Sheesh. At least I saved the original scale to keep the factory design. The meter board also has a second revision which has a trimmer across the signal meter. Mine just has a 1K resistor. I replaced it with a proper trimmer, even though I have no idea how to adjust it properly. The radio part was a bit more complicated. This is a discreetly built digital tuner. The oscillator frequency is derived from a quartz and a divider based on the output of the frequency matrix. There are 5 PCBs to handle that: the antenna amplifier, oscillator, mixer, IF stage, and finally the stereo decoder. Good thing I have an alignment guide. And again, no output. Checking all the signals and voltages. During the troubleshooting effort, I saw that one of the digital ICs was in the socket upside down. I flipped it around, but that turned out to be an error in the PCB drawing. Great! Now I have to replace that chip, because now it is broken. Turns out that one decoupling capacitor in the IF stage was shown upside down as well. When I replaced it with a properly oriented one, I finally got audio output. Woohoo! But then again, the audio degraded quite fast from wow to oh my god. Again, checking the signals and following the wires revealed, this time I put in a capacitor back to front. Whoops! The audio output got saturated and would only play the lower part of the waveform after a few seconds. It sounded like a detuned reception, so I was hunting all over the receiver again. The side panels are wood grain, but against all hopes, it's not actual wood, but rather particle board with a very thin, look-like-wood cover. I tried to remove that layer, but while it was in very rough shape, it stuck to the base like there's no tomorrow. I decided to sand it down a bit to roughen up the surface and then glue some actual veneer on top of it. Sanding and 2 layers of clear coat give them a nice look again. Sweet! I did, however, lose one of the metal inserts that was supposed to keep the screw from digging into the wood too much. Getting some new, similar washers and cursing heavily because the nice screws were now slightly too short and required some hammering and tweaking to get the wood panels to actually hold. The missing knobs were bugging me. I wanted this device to look fine, at least. New knobs in a decent style were quite expensive. OpenSCAD comes to mind again. And to have a nice design, I glued on a piece of aluminium sheet to the front and whittled it down to a common diameter. Painting them black and then sanding off the front to create a brushed aluminium look rounds off the effort. Nifty! Now that the knobs and buttons look so nice, the banged up front panel is a sore sight. With a heavy heart, I decided to go all the way. Sanding off the old paint, spray paint the background, and then silkscreen print for the white lettering. It would have been so much better if the silkscreen chemistry hadn't expired since the last time I used it. F***! This took a total of 6 tries to get a decent enough result. I might eventually redo it though, when I have a better silkscreen setup. I had to add a C-clip to the knobs to make them grip the axle. Also, the station preset knobs turned out to be the wrong shape. I had to remake those in a slightly different design. Now that all things were connected and working, I tried to enjoy some music, only to be annoyed by some very angry noise during louder portions. To the scope again. Turns out that the left channel was clipping on the positive edge, but only during louder portions and only with the speaker connected. The headphones alone worked fine. I followed the signal around and finally concluded that the output stage couldn't handle the current draw on the positive half of the wave. So my suspect number 1 was the pull-up transistor in the circuit. I ordered a replacement and, just for the lols, I checked my stash of 3 different TO3 transistors I have around. And what would you know? One of them actually was a direct replacement for the suspect one. Where's my lottery ticket? But even replacing the transistor did not fix the issue. I was close to giving up, but then I had an interesting effect. Pushing down on the connector made the audio sound better. Aha, a clue! The connector measured fine, however. So I peeked near the connector and started reflowing some solder joints in the main current path. I suspected a crack in the PCB connection, but what I actually found was that the set of power resistors, The solder joints were crusty. One leg didn't even take solder. That was it. A hairline loose solder joint that couldn't handle the high current demand of the speaker. And while I was at it, I also added a sill pad between the two different heatsinks. The main transistors are on a huge heatsink that has active cooling with a fan if needed, but the ones that actually get hot even in low power usage are tucked away under that, without actually touching it. The sill pad will help transfer the heat out to the larger heatsink. And after adding all the panels and covers back to the device, it is done. I can listen to the radio in awesome 1976 hi-fi style. Now I just need to find some decent speakers so it actually sounds like hi-fi. And that's it. I now have the core elements of my retro hi-fi system. I still might tweak it here and there. The silkscreen print needs another try, and some components could be replaced to run cooler, but it works fine and looks spiffy. I hope you enjoyed this project as much as I did. See you next time! But the bulk of the work is done by I shouldn't have eaten that tuna.